This video is going to use the rule of when you have intersecting chords. So I'm going to use the diagram for number 3 as an example here. We have two chords that intersect. The rule is that it doesn't matter which chord you start with, but you would multiply the lengths of A times B and then set it equal to the other chord, C times D. So I'm going to use this rule. I'm just going to do it with the numbers that are in number 3. So first, if I can erase this here, let's just read number 3 and label everything. So it tells you that you have chords A, B, and C, D intersect at E. CE is 10, ED is 6, and AE is 4. What is the length of EB? So again, you just start with a chord and you're going to multiply it into the two pieces. So 10 times 6 equals, now go to the other chord and multiply the two pieces, 4 times X. So it's like completely, taking that that chord. 10 times 6 is 60, 4 times X is 4X, divide both sides by 4, and you get 15. Now, a question like number 4, when you don't have a diagram, you definitely want to draw one, because otherwise it's hard to see what's what. All right, so I've already drawn a diagram, a circle, and I have two chords. So it says chords A, B, and C, D intersect at point E. So the point where they cross is E. Now, the measurements might not work out to be how it looks in the diagram because we just drew it, but that's okay. AE equals 8. Now, AB equals 20. Problem with that is AB is the full length of the chord, and it's like piece times piece when you multiply it. So if all of AB is 20 and that part is just 8, you want to subtract 20 minus 8. So from E to B is 12. Okay, DE is 16, and then what is the length of CE? We don't know, so that's X. So start with one of the chords and just multiply the two parts of it. So 8 times 12 equals, then do the other chord, 16 times X. And then you just solve it. So 8 times 12, 96, equals 16X. Divides both sides by 16, and you get 6. Okay. One more together, number 5. In the diagram below, circle O, chord DF bisects chord C, BC at E. So it's splitting this chord BC in half. It's bisecting it. If BC equals 12, well, there's no point in putting the 12 in because we need the two pieces. But if it's bisected, I know it's split in half, so it's 6 and 6. FE is 5 more than DE, a little algebra here, 5 more than DE, so that's going to be X plus 5, which means DE is just X. Okay, let's multiply piece by piece, right? So we have X, that piece, times, we put parentheses, because the rest of that chord is a binomial, so we need parentheses because we're going to have to distribute. And the other chord, the two pieces are 6 times 6. Okay, so distributing, we get X squared plus 5X. Equals 36. We're going to subtract 36 from both sides because we are going to have a trinomial. And this is going to be, we can't combine like terms, I'm just writing them all separate, but this is going to be a quadratic equation. And we multiply by either GCF, D2PS, or trinomial. In this case, it's a trinomial. So I'm going to make the two parentheses. We have to find two numbers that multiply to negative 36 and add to a positive 5. That would mean it's a positive 9 and a negative 4. Then because it's equal to 0, we're going to have to do the t-bar, find the roots here. Change the sign, we get a negative 9. Change the sign again, we get a positive 4. But because this represents the length within a circle, the length of a chord, negative doesn't make sense. Reread the question. The question says to find FE. Well, FE is X plus 5. So X is 4, right? So 4 plus 5, that means the length of FE is 9.